Okay, so we are live. Hopefully the audio is working. It appears to be working. That is good. Okay, cool. Hello, everyone. Happy Friday. Nice to see some familiar faces in here. We'll give it another minute or two. All right, why don't we dive in? So thank you for joining me on this Friday evening. I'm gonna try and keep this one to like an hour, like just an hour. Maybe we'll go to an hour and a half max. But I have tended to ramble on in these live streams, so this one I'm gonna try and put like an actual like cap on it. So we'll see how that goes. Fingers crossed. This particular happy hour, at the request of some of my students, is going to be on Human UI for Grasshopper, which is a plugin that allows you to build user interfaces for your Grasshopper scripts. I have not prepared any like particular material for this, so everything is going to be kind of like improv. The good news about that is that if you have questions or you want to see something in particular, or you have a particular idea about a way to do something or whatever, like please just shout in the chat. We will let this be free-flowing, free-form, and explore whatever you're interested in with respect to Human UI and maybe even a little bit beyond. I anticipate we will probably also look a little bit at MetaHopper because these two actually play together really nicely. When I build Human UIs myself, I tend to use MetaHopper almost exclusively. I think it's one of the more like flexible and extensible ways to use the tool, and I will show that. But we'll start with the basics. You are not expected to have any prior knowledge of Human UI to follow along with this. So I will try and kind of illustrate the basic concepts of what you need to know in order to use it. And then we will steadily delve deeper into the finer points and the details. So without further ado, there are a handful of basic things you need to know before using Human UI, or in order to use Human UI. Every component or every definition that utilizes Human UI has kind of like a few key parts to it. The first and perhaps most important of these parts is launch window, which is how you actually get a window. So launch window expects a Boolean to tell it whether or not to show. If we just supply this, we should see our window right away. A name, a width, a height, and then a sort of like a root font. You can also control fonts with a little more detail, but if you want to specify a font family that you want to be used throughout your window, this would be the place to do it. But for our purposes, just like this will work. And the width and height, too, are really just a starting width and height. The window is itself flexible and scalable, so you don't actually need to specify it here unless you want to. So the next thing that every Human UI definition requires is a set of elements. These are the things that go in the window. So the kind of classic example is to take something like a slider. We'll just make a value here in Grasshopper, which, let's say this controls the radius of a mesh sphere, for instance. And I'll just pull this aside so we can see what's happening in 3D. This slider is controlling the size of that mesh sphere. Let's choose one that goes a little bigger. So I'm going to do like this. And now we have a little bit of a wider scale. And so we want to take this element and we want to publish it to this window such that we don't need to actually use it here in the Grasshopper context. So in order to create a human UI slider, we need to create a UI element slider, which is the create slider component, which will take a reference to this slider in the Grasshopper UI, which we produce by simply connecting it. And this is going to create a human UI slider element. So when I'm talking about elements, I'm talking about the kinds of user interface components you might want to insert into a window. So the next trick is to actually put this element into this window. And so that's the kind of third basic piece of any human UI definition is the add elements component, which will let us take a reference to a window and then a list of elements. And as soon as we do this, we see this slider start to manifest in the window. Now, one of the first reactions people have is they want to move the slider and see this change. And of course, this doesn't work. If I were to redesign human UI today, I would probably do it quite differently, and I would probably make it somewhat easier to set up, and these kinds of, kind of automatic bindings would be a possibility. But for now, we're going to live with the way things currently are, which is going to require a little bit more setup. Now, there's always a trade-off between the amount of setup required and the amount of kind of power and fine-grained control you have. So I think that's the strength of human UI, is that you can build really, really complex and sophisticated UIs using only Grasshopper components with human UI, but it does require a fair bit of setup. So how do we solve this problem? How do we get the value in this window back out to our definition? Because clearly this mesh sphere is not changing. So the way we do this is with a third component here, or I guess a fourth, which is the sort of like the fourth part of every human UI definition is the value listener. So the value listener takes a reference to a human UI element, and it will maintain a live connection to the value of that element. That's why it's sort of listening for those changes. So now we can see that as I change this slider, it's actually updating the value that's coming out of the value listener. And so one of the things about human UI is that it does sort of require you to rewire your definition a little bit, although we'll show some tactics for maybe avoiding that a little bit later. So I can replace what was connected to this slider with the value of the slider in the UI, and now I can see that my mesh sphere is changing on the basis of my human UI slider. So far, so good. So this is, in fact, a sort of complete human UI, but one thing that we may also want to do is actually update a value in the UI on the basis of something we've calculated. So let's create another element here. Let's create a label which is going to report, let's say, the volume of this sphere. So I'm going to go back to the Human UI tab. I'm going to find a create label element, and I'm going to supply it with some text. This asks for some text, a label size, and a justification. And the thing that beginners with human UI almost inevitably do, which I have come to realize is my failing, not theirs, is to try to feed this directly. So we might get our mesh volume out of this, feed that text into the label, and then add that label to add elements. I'll hold down Shift so that I can connect both wires. And now this is going to render the volume of this sphere as I adjust the slider. But immediately we get the situation of a sort of a lock condition where I can no longer move this slider. Also, add elements has turned orange, and there's this enormously long error message that pops up. Let me summarize that error message for you, which is that in general, in fact, as a rule, you should not feed the inputs to any element with the output derived from any value listener. So let me say that again. No input components, none of these elements should have their inputs driven by or dependent on any value that comes out of a value listener. Now, why is that? That's because the add elements component effectively like redraws the window. It just sort of resets everything. This is an oversimplification, but for the sake of argument, let's say that add elements basically resets the window every time it expires, or every time it executes. So let's see that in another way. If I move this slider around and I plug this label in, you'll see it resets to whatever the default value was that was supplied to this slider. So this slider has been populated with a default value of 16, and as soon as I cause this component to execute, with or without the label, like if I just change this and then I say enable, it will re-execute and it will set this value back to 16. So every time something changes that's feeding into add elements, all of the user interface elements are reset back to their defaults. So this poses a problem for us because we want to change this value. So the answer to this and the pattern that you'll find throughout Human UI is that the way you solve this is you do not feed the value in directly. So we're going to disconnect this volume input from the label. Instead, you supply, just like we did with this slider, a default value, which we'll just say is like, volume. It doesn't really matter. And then we're going to use one of these red components. So the icons are sort of color-coded to give you a hint, which is that there are elements and then there are output components. And these typically say set somewhere in the name. So we're going to use the set slider component. And as a rule, any create component has a sort of partner set component over in the output tab. So I'm going to use set slider or set label or set expander or set checkbox to update the value of an element that has already been added to the window. So anything that's going to change on the basis of something I do in the window should then populate a set component to then update that value. Whereas these components should be reserved for creating a new instance of that value or a new instance of that element and setting it to a default value. So let's use set label contents. We're going to pass it a reference to this label. We're going to connect this label in, and then we're going to plug in the volume. And we're also, the one thing I've forgotten is to actually add this label to the window. So now our add elements component is gray and happy. And as I modify the radius, the volume updates accordingly. So these are kind of like the basic steps of every human UI. You've got a window that you launch, some elements like a slider and a label. You add those elements and populate them with default values. And then you use a value listener to get updated values back out of them, plug them into the logic of your definition, and then use any values that you wish to update or output back to the window with a set component. And basically everything we'll see today sort of follows that pattern. So we can add all kinds of elements to this window. So we're not limited to sliders. We can create drop-down menus. So let's do that. Let's create a pull-down menu. And we're going to create, let's say, a list of colors. So I'm going to create a list here in just like a panel. And I'm going to say, red, blue, yellow, green, chartreuse. Make sure that is a multi-line data panel. feed that in. And, oh, I've plugged it into the wrong input. This is asking for an optional label. Oh, thank you. My cocktail has arrived. Thank you, baby. Oh, that's good. All right. Now we're in business. So, all right, are we back? I restarted OBS. It's green now. Let's see. Just waiting. I always keep my stream up on like another machine just so I can see. Hooray. Okay. It looks like it's working. Okay. So hopefully we didn't miss too much. But just to recap, I've created a pull-down menu with named color, which creates this label. I've created a list of color values. I've attached a value listener in order to get the value of that color back out. And as I flip through this, it will update. And if we're lucky, we can rely on the Grasshopper magic of being able to use sort of string to color conversion. And if I just pass this in, let's see what happens. Look at that. That is a chartreuse-ass sphere if ever I've seen one. So, what else can we do? We can display images in here. We can display 3D geometry. We can make various controls, like there are actually many that map to the UI elements in Grasshopper, like a gradient, graph mapper, Boolean toggles, all kinds of things. Okay, it does appear it's like it's got giving me green square, which I think is a good thing. Is that better? Okay, I think that's better. Oof, sorry. Thank you for your patience. Those are we call those sip breaks. Okay, so we can do lots of things. We can put in gradient editors. We can put in graph mappers. We can populate data tables. We can control the layout. We can style the window. If any of those things are of particular interest to you, please shout in the chat, and I will I'll move those ahead in the non-existent schedule. But I think for now, what we'll do is I always like the image folder example. So let's go ahead and find like a folder of images somewhere. I'm going to use mine, which has very good images in it. I'm going to grab the path. I'm just going to copy that. I'm going to paste here in the window. And I'm going to make a little like image selector. So we're going to use a few components from Human here as well. So we're going to use directory contents in order to get a list of all of the values in there. And I'm going to filter this by star.jpg in order to make sure that I'm only dealing with JPEG images. That should give me a nice list. I'm going to actually populate my pull-down menu. Actually, let's just make another pull-down menu. Why not? I'm going to use the names as the values in the list. I'm going to add that pull-down menu to my window with add elements. And then I'm going to use the value listener to pick that item. Now, value listener provides a convenient index output as well. So I can just use this with list item in order to grab the corresponding full path of the image. This is the full path. This is just like the name of the file, so we don't have to see, the full path. And then we can use that to create an image. So there is a create image component. And we're going to need like a dummy value, a default. So I'm just going to use the first item off this list as my default. Pop it in there, plug it into our window. And then we're going to use this, the item that we're grabbing from the value listener with a set image component such that these things are dynamically linked. So I'm going to take the image component, and then I'm going to pass it a new path to that image. So if I grab Zaha, I get a pretty little image of Zaha. So Luigi wants to know, was it written with WPF? And the answer is yes. This window is WPF, and it relies on a lot of kind of like baseline WPF concepts. So all of the container types and things like that are sort of native WPF ideas. And in fact, there's even a mode in which you can compose WPF XAML, which is like the XML-based markup language that WPF uses as kind of like a short form to describe UIs that you build with WPF. And you can just feed XAML directly into the window. Gloria was interested in styling the window in elements. So let's do a quick diversion there because I think that's really fun. So by default, the window uses a kind of blue light theme. Under UI main, there's a set window properties component, which you can connect to the window and set some more advanced styling options. So we can set the starting location of the window, which is kind of fun because you create like a point, and then that point will actually like move your window around. So I'm just using a reference point here in Grasshopper, but if I move this, my window will move accordingly. So you can do all kinds of like, you know, you could have like a kangaroo script, like have your window bounce around with real physics if you were feeling like really evil. We can also set the theme. So this theme wants an integer value, but really it's just a choice between light and dark. So we can choose a dark theme, which some things don't look great in this for whatever reason. Usually it'll reset and it'll look okay. And then we can also choose an accent color. So the accent color is a little bit funny. It expects one of a set of kind of fixed values. And if you right-click the component and choose Create Accent List, it should actually create that component for you with a list of all of the available accent colors. And you can see now, if I choose a color like emerald, I now have a window where, you know, the slider is green and the header is green and so on. The XAML question, so I'm going to be, I don't actually like remember my XAML very well, but let's see if we can just like do this real quick in a Visual Studio project. So there is a, Visual Studio comes with a kind of visual editor for XAML. So if I create a new project, which is a WPF application like this, it will be set up in such a way that there's this kind of visual editor for kind of WPF windows. And it includes this kind of funny syntax called XAML, which apparently I have on here twice for some reason. There we go. So I can do things over here. I can grab my toolbox and start adding objects, like I can add a tab control into the window, and I can add things like let's just do like a shape or something. I could drop in an image, but I won't. I could drop in a web browser. I can drop in a scroll viewer with certain items in it. And there are all of the, you can edit sort of all of the properties over here. I don't actually recommend this as kind of like a primary way to author UIs because they won't have the associativity with the Grasshopper environment. But let's just add like a, can I do like an ellipse or something? Yeah, let's just make like a cute little ellipse over here. I don't know. Oh, did I put it like inside the scroll viewer? That's what I did. We'll put it out. And then I can, you know, I could style it or whatever. It's good for like visual and static items. This is not the best way to do other things. You can get pretty sophisticated with this, but what we'll do is we can copy any of the stuff within this grid. So like this tab control, this tab item. Actually, we could copy the whole grid. Let's do that. So from grid to /grid, this is XML syntax, so it looks a lot like HTML or other things where it has these sort of angle brackets. I can just take that text, put it in a panel, the entire thing in a panel, and then I can use the create objects from XAML component. And then this just creates elements, which I can feed directly into my window. And you can see that I've got my tab item, I've got my ellipse, I've got my scroll viewer that has no stuff in it, and so on. So I don't think that's like the best way to work, but it is a useful way to kind of like understand the kind of internal logic of this system, of WPF in general. And if we get to it, maybe later I'll show some like complex property setting or whatever. We'll get there. I'm going to delete this one for now. There's also a question about combining human UI with Speckle. That feels maybe a little advanced, and I have to confess I'm not like super confident in Speckle either. Maybe if we have a little time at the end. There's a lot of like comments about like being able to design web applications, and let me say, if you want to do that, you should probably not use human UI because WPF is not super like web compatible. I've often thought about building a library that like creates, you know, like interactive web code based on Grasshopper components. But I would say if you really want to put your Grasshopper script on the web with some sort of like custom interaction, I would say use Hypar for that. And maybe if there's time a little later, I can show a little sneak preview of Hypar's functionality. Hypar is the company that I work for those of you that don't know. We're currently working on some tools that will allow you to publish the logic of your Grasshopper scripts to the web and interact with them. So maybe I'll show that a little later. So you can actually embed a browser directly in a human UI. So if you really wanted, I don't recommend this either because it's just kind of like a crappy browser. Where is it? There's like a create browser, is there not? Create, I thought there was. There was at one point. Oh, there it is. Here we go. So I can provide a URL like, I don't know, self-serving as ever. We'll use my own website, plug that in, and connect this as well, holding down Shift as ever. And now we've got a little iframe with my website in it. And because it's small, we're getting the mobile display, but this is like an ActiveX web control, and it's like horrible, to be honest. So I don't recommend doing much with it. You can control like its width and height, but it's really like not great. It's kind of a pain. But I mean, you know, you can imagine using this for some cool stuff. And yes, we'll get there. Okay, well, here, remind me if I haven't gotten to it by, let's say 7:15, no, 7:30. If we haven't got to it by 7:30, I'll do a cheeky Hypar demo. Okay, so let's see. Actually, this is already, I want to show some of the more advanced MetaHopper stuff because it seems like we have a pretty advanced crowd joining us today, which is good. So I want to show you how I like to use human UI. It takes a little bit, even more setup. It's like even more cumbersome, but once you get used to it, I feel like it's a really good way to go. So let's imagine a new scenario. Let's say we have like a box here, and let's create a slider from 0 to 100, and let's create a few of these, which are going to be our kind of control the dimensions of this box. So the first thing I want to show is just that like I use human UI with snippets because there are so many components for setup. I usually do this, set up human UI, and create a little pre-configured arrangement that includes the window, the add elements, and I tend to use an entwine rather than, as I was showing before, just kind of feeding everything with Shift into the window, because if your data trees are not exactly aligned, you will wind up with like weird ordering things, and an entwine has the effect of basically flattening its inputs, and it ultimately gets flattened when it goes into add elements anyway. So I use an entwine as a shorthand to basically say like force stuff in this order. So what we're going to do is we're going to use MetaHopper to grab all of these sliders. So I'm going to use get selected. Actually, let's use let's just use get selected. So getSelectedObjects is a MetaHopper component where you select some objects and hit select, and it will provide a reference to those objects. So this is actually pointing to the real like Grasshopper SDK elements, these number slider objects. And the create slider component, and in fact many of the create components in Human UI support not only a direct reference or some like direct value, but also an abstract reference from MetaHopper. So I can just plug all these sliders in, plug them in here, and now all the sliders are here. And the cool thing about this is that I haven't had to deconstruct my definition. I've just provided a sort of dynamic reference. And the good thing is this will enable me to do two-way binding. So I can use, let's do a set object value and a value listener. So value listeners from Human UI, set object value is from MetaHopper. I can take these objects, which is this list of 3 number sliders, and I can take the 3 values, and I can see that those have branched onto their own branches, so I'll probably want to graph this, and I can plug these values in, and now we've actually set up a totally decoupled two-way binding with the elements in the Grasshopper script and the Human UI. So what this allows you to do, and this is something that Brian Ringley and I really perfected at Woods Bagot, was this technique of developing UIs where they're totally independent from each other. So this script just works. It totally works as it is, but, and actually I lied, it's not really a two-way binding because if I change this, it doesn't update this. So that's a little bit of a lie. It is a decoupled one-way binding, I suppose. In any case, this becomes a really good way to kind of develop your scripts and have a UI for them when you need it, but also have a way that you can just like hand somebody the script without all of the Human UI stuff and have everything still work. So we can do this with all kinds of elements. If we want something like a pull-down menu, we can use something like a value list. And actually, you know what? Let's do our image example one more time because I think this is pretty fun. So I'm going to go get my images link. I'm going to paste it. I'm going to use item selector, or I'm going to use, directory contents, getting ahead of myself. Now I'm going to use, and we'll do star.jpg because I've got other stuff in here. Then I'm going to use item selector. And actually, let's do a value list example too, just because we can. And I'm going to use this, and I'm going to use a nice human component, not Human UI, called filter by item, that lets you take a guide list and a selected item, and then you can filter any number of additional lists according to the selected item. So that works really well with this item selector. So this is going to have the effect of like the same thing as our list item we did earlier. And what we're going to do is now we can use this to populate our create image. So as before, we're going to need like a dummy image. So I'm just going to grab like the first item out of this list. And I'm even just going to internalize it just to maintain our perfect decoupling. I'm going to do a create image. Whoops, not a create light, a create image. And we're going to add this in. And then we're going to use, in order to couple to this value listener, we're also going to drop that in. So we're going to use the select object, get selected objects from MetaHopper again. And we're going to get, this requires a little more setup. We're going to need get list data from MetaHopper, where we pass it a reference to that param. Whoops, I didn't select it properly. There we go. Here's the param. This is a reference to that value list. This is going to give me all of the values in the list, which I can put in a pull-down menu. And I can even, I can say like image, where that's like the nickname of this component. And this should still give me back that thing, so I can use that as the label. And then I can add this here. And now I've got image mountains, and we just need to do the flip side, which is a value listener and a set object value, where I can take the value coming out of the value listener and pass it back a reference to this param. And now, as I flip through this, it's going to change this slider. And then I can use the output of this, which is like the image that I've selected, to populate this image. So remember before we use we used set image with a reference to the image component and a URL. I could just pass it this. That would satisfy being decoupled in a certain way where, you know, if I delete this, everything up here still works. So that's like still reasonably satisfying. There's my puppy. Or I can use a reference to this object if I want. I can just say this is like image URL or image path, let's say, since it's not really a URL. I'll show you another way to reference an item with MetaHopper. We'll say image URL in a text field here, and we'll say get object by nickname. And then I can use param value. You know, I could do this. I actually think, oh, is it not working? Object by nickname. Is it lowercase? Or image path, that's right. See, the martini's getting to me. Here we go. Okay, now I've got this object. Now I've got the data coming out of it. I actually think in this case, what I would do is use a telepathy sender. And the reason is that this way I don't have to worry about like refreshing the input. And yes, it is getting recorded. All of these like live streams will show up on my YouTube channel when we're done. So I've got this sender. I'm going to use receiver equals ... which is a little shortcut that will create a telepathy receiver. For those of you that don't know, telepathy is a component that is a sort of self-wiring param, where if you point it to a key, it will just automatically wire up that key. So a sender with a name will get automatically wired to a receiver with the same name. So I just created image path. I'm going to feed that in. And now as I like flip through this, it should update the image, which it does. So now we've got like a totally decoupled system over here. And there we go. Okay, I'm going to look at some questions. Is there a way to render the element into control window? I'm not sure I understand the question. Which element are you talking about, Fernando? I'll wait for you to answer just because there's like a pretty long lag. So let's see. What else can we do? Here's, let's get fancy. I think what I'm going to do is, these are all coupled. I think what I want to do is make a mesh out of this box. So here's my box over here. And I'm going to mesh this BWrap. And I'm going to do so with some mesh settings that have like a max of, I don't know, 8. Let's see where we are here. Yeah, that looks good. Then we're going to deconstruct the mesh and get the, I'm going to use, actually, yeah, let's use an attractor for this. We're going to make this a pretty colors. I love pretty colors. So we're going to take the distance from every mesh vertex to this. We're going to find the bounds on the distance to get the sort of like range of possible distances. We're going to remap it in order to set it back to the domain from 0 to 1. So now we've got a normalized set of distances. And then we're going to feed that through a gradient, which is what all of this was leading up to. I'm going to use this gradient. And I'm going to use that to do mesh colors so that these colors being fed through are going to affect our mesh. And that's going to be a function of the distance to that one particular point. So as I move this point around, we get different colors on the mesh. Let's hide everything else. And we'll hide our mesh edges, and that's beautiful. So what we'll do to keep up with our sort of decoupled logic over here is we're going to create a gradient editor, which we can feed into this. And the gradient editor, by default, is just sort of an interactive thing. We can connect it to a reference to a gradient or supply some presets if we want. So again, what we'll do is, oh, why is this mad? BREP to BREP. What is that about? That is a valid cast. Don't you tell me what I can't do. Why is that mad? That doesn't make any sense. Oh, you know why? Because my sliders are 0, of course. Blah, blah, blah. Okay. So what we'll do is we will grab a reference to this gradient. And this time I'll show yet another way to get a reference to an object. So if I give the group a name, I'll say this is my gradient control. Then I can use objects by nickname. And we'll say gradient control. This time I'm naming the group rather than naming the object. And then I can say objects in group, which will give me back a pointer to that gradient. And now I can feed that gradient in here. And now it's like preset to this. I should really set these sliders so that they have a more sensible range. And let's see. And it also wants, so these are available gradients. So I could just use this one, or you can also just like create gradient objects like this with like a couple different values to like pre-populate a set of possible ranges. And we can just plug these in too, huh? I think. And then let's see, set to true in order to show the presets. So now I can pick between the presets that I've supplied there. And then we're going to use our reference to this gradient control again with value listener, which is going to give me back the gradient value, and set object value, where I pass it the object and I pass it the value. And now whatever gradient I have selected in my gradient viewer should propagate back. And just so we see what's happening, it's actually like setting the value of that gradient control. And this should also, like, you know, it should respond properly to any like specific like point changes and things like that. Oh, so the question was like, yes, can we put the geometry in the window? That's a great question. Yes, let's do that. So you can put geometry directly into the window, although I'll say this, I think a lot of people get excited about this possibility. I tend to think you should rely on the Rhino window for what it's good for, which is rendering 3D geometry, and you should rely on the Human UI window for what it's good for, which is rendering UI elements. But if you have some sort of like secondary geometry that you want to show alongside your real geometry, then yes, that's a perfect use case for something like a Create 3D. So the sort of simple way to do this is to say, I've got some geometry. We're going to do a Create 3D view. And as usual, I'm going to pass it a piece of default geometry, like a mesh sphere or a mesh box. It doesn't really matter what you supply as the default. And we're going to add a new slot. We're going to add this in. And you know what? These sliders are driving me nuts. So I'm going to show you one more fun and lazy trick with our sliders, which is we can do set slider properties with our references to our 3 sliders up here. And I'm just going to set all 3 of their ranges at once, because that's the kind of guy I am. 0, 1 to 100, let's say, becomes the range of those sliders. And there they are. And we probably have to refresh this guy as well. But now the minimum bounds is 1, so we shouldn't wind up in the scenario we were hitting before, where we had 0 values, which were causing invalid meshes. So back to what we were doing, 3D. We can now use set 3D in order to populate this view with an updated mesh. So in this case, this is another case where I would probably use a MetaHopper, or a telepathy sender. So I can just take the mesh version of this, box mesh, say receiver equals ... is that shortcut that I very quickly went over, which just is basically a shortcut for create a receiver that points to the most recent key that I created. But of course, if you just create a receiver, you can also use the keys menu to go find that box mesh, and it will be wired up automatically. Put this guy in. And now we've actually got a 3D view of our mesh down here in a little window. So it's pretty big, but in fact, if I zoom out, there is our mesh, and as I manipulate this geometry with the slider, it should update dynamically. I honestly can't remember if I support vertex colors. I kind of think I do. Nope, apparently I don't. Never mind. So if you want to do vertex, oh, that's right. If you want to do vertex colors, you actually have your work cut out for you. So you should probably just rely on the Rhino viewport if you want to do like false color visualization of stuff. However, you can dynamically alter the color. So one component I haven't shown is a color picker, which we will add to the window. And this is going to let me like pick a color from this like janky built-in Windows UI. And then I can use that to set the color with which I render. Oh no, sorry, value listener. Get the value back out. Whoops. That's the martini dragging those wires. So now I've got my tiny little box here. But you can see that as I flip through different colors, it will actually like render them with those colors. So I think it would be good, because I've been focusing mostly on the sort of individual components. It would be good to maybe show a little bit of like layout stuff, because I think this is where things start to get a little more sophisticated, and where you have a ton of control with human UI that you wouldn't have with, say, the like, you know, the remote control panel or other mechanisms for exposing the components of your Grasshopper definition in the UI. So here's what we're going to do. In addition to all of these elements, we also have what are called UI containers, which let us create various ways of organizing the content that we drop in. So I think one of the best of these is the tabbed view. So we could say that everything from here, like these are the sliders, this is the image. So let's put the image and its controls in its own tab. So we're going to create a tabbed view. Tabbed view says, what are the names of your tabs? So I've got box controls, and I've got image controls, let's say. I'm going to make that a list. This is going to be the list of names. And I can set size. I can set the icon source if you want to get really fancy. And if you zoom in, you can add individual inputs for every one of the tabs that you create. So what used to go into add elements, we're going to actually disconnect this. If we just plug all of this in, it will now show up under the tab box controls. And now image controls show up somewhere else. So I want to disentangle the image controls, which I believe are this UI element and this UI element. Let's just try it. And I'm going to do another entwine for this input such that I can control the order. And now image controls has got the interactivity for my like little image picker, and box controls has everything that's relevant to the box. And you can do this with a lot of things. You can create grid layouts. You can create layouts that stack. I mean, so by default, the window contains what's called a stack, which just basically says put everything one after the other. Now, stacks can also go horizontally. I don't know what this will look like if we try it, but if I take all of my elements and I say, let's make a horizontal stack, this is probably going to look like shit. It's going to try to, it actually didn't even work exactly, but it did start to stack some of these elements horizontally. I suspect that the gradient control is special, so it probably like, oh, I know why. Maybe if I just flatten it? Yeah, there we go. Okay, now it's made a complete horizontal stack of my 3 sliders, my gradient control, my 3D view, and my color picker. Now, actually, the accident that just happened, my sort of mistake, is also a pointer to something that's really useful, which is that like by organizing things in branches, you can actually make like parallel horizontal stacks and have your like X sliders all, or your 3 sliders all go together because those are all fed in here. Those are on their own branch. Therefore, they become their own horizontal stack. There's a ton of control in how you set this up. Some other notable controls. The tab viewer is really popular. You can create individually scrolling regions. The grid is really complicated. And actually, I think Mark authored something called a simple grid. That's Mark Seep, who's another one of the major contributors to Human UI. If you create a simple grid, you can place like a tree of elements and you can specify their kind of row definitions and column definitions. And I think it just sort of like automatically matches up the rows and the columns with the tree. Whereas setting things up with the proper grid requires even more work. You really have to like assign every single one a like column and a row, which is a pain. The expander is pretty fun. So let's put our like 3D view and our color picker into an expander. So I'm going to take, and as usual, I always use an entwine as an input to anything that's going to be like a container, just so I can maintain control over the order. But now I've got a sort of separate little expander, which contains those 2 components. And one thing I should show is you can take this and you can manipulate also the size of elements. So let's take this expander, for instance, and let's see if we can get it to like stretch all the way across the window. So we can use adjust element positioning. There's appearance and positioning. Appearance will do things like color and background color. Positioning will do things like sizing. So if I pass it this expander and I set the horizontal alignment to stretch, sometimes that's sufficient. Sometimes we might also need to specify, this is a little crazy, a not a number object. Is that going to work? No, it's not happy about that. Let's see. We've got a horizontal alignment stretch. Yeah, I'm not totally clear why that's not working. Normally the, oh, you know why? It's probably because we're putting it in this stack and maybe the stack itself is not. Let's just try it. Sometimes it's useful to sort of troubleshoot an element by itself. So you can see that now this expander is set to scale, which is what I wanted. And for some reason, the element that I put it in, which was this stack, let's try this stack by itself. And there's some like funny execution stuff that happens here. Sometimes if things are not behaving the way you expect, it can be useful to just hit F5 and cause everything to recompute. So let's see. Yeah, nothing appears to be showing here. We've got our horizontal stack. I think it's the stack that's giving me trouble. So I'm just going to take that back out and we're going to plug our tabs back in. And now, yeah, now our little 3D view and our color picker are stretching to fill the window. So that's nice if you're into that kind of thing. Let's see. So Fernando wants to know, can I use Human UI to link my definition using Rhino Compute Service like Shapediver to construct my control window for my website? The answer is no. Human UI is really only useful for setting up a user interface running on the desktop in the context of a running Windows Rhino 6 instance, a Rhino 6 or Rhino 7 instance. So if you want to put stuff on the web, you really should be looking at another tool like Shapediver or like Hypar, which I think I'll show very quickly. In fact, I promised that I would do this before 7:30, so let's do it. Unless there are any great questions, we can return to Human UI if there are any like questions a little later on. But I just think this is really fun. It's all I've been working on for the last several weeks, so I'm pretty excited about it. I want to show, and it does seem like there's a lot of interest in being able to put stuff on the web. So let's use this definition as an example. So I'm just going to take my rainbow color cube, and I'm also going to control this point with 3 more sliders. Actually, you know what we're going to do? We're going to replace it with a curve. So I'm going to create a polyline here. And I'm going to say, instead of using distance, we're going to use curve CP. So that I've got my curve. I'm going to use my vertex closest point, and I'm going to use that distance instead of the distance to the attractor. So we're making a curve attractor instead of a point attractor. So now what I want to do, so that's kind of fun, right? What I want to do is put this on the web in a way that someone else can interact with it. So the way we're going to do that is we're going to use Hypar. This is still in beta, so there's a reasonable chance it might, might flake on me, but let's try it. So Hypar asks you to, so there's a Hypar plugin, which in fact, even if you're not part of the beta, you can download this already and start playing around. It's on the package manager. If you're in Rhino 7, you can type package manager, download the Hypar plugin. If you're on Rhino 6, you'll need to type test package manager. Even though it looks like it won't autocomplete, it will in fact work, even in Rhino 6. And you'll install it. And there's a set of components. They might look a little different than this because this is under sort of rapid revision that allow you to set up information about a function, which is what we call sort of the logic of a script that you publish to the web. So what I'm going to do is grab a couple function input components to basically tell my definition that I want to use x, y, and z as the variables. So I'm going to take x, I'm going to take y, and I'm going to take z. And then I also need to be able to pass this geometry back out. Oh, actually, we're going to do one other thing, which is we're going to take this polyline that I created, and we're going to make that an input as well. So I'm going to plug this in. And then we're going to do a model output, which is basically like, what do we want to render into the web view? So I'll say this is my psychedelic cuboid, really. We'll pass it in. And we can save this definition as psychedelic cuboid. And I'm gonna use one other component, which is right now necessary, although very soon you won't actually have to do this in advance, which is called Hypar function setup. And I'll just say psychedelic cuboid. This is where you specify something like the name and the description of your function. Now we're gonna go to the Hypar website where you can sign up for free. Hypar is currently free. This was, by the way, this was not intended as like a marketing thing, but I think this is fun, and I think a lot of the questions around like, web publishing of stuff are relevant to this. So in the near future, as a Hypar user, you will be able to add functions in this view. Normally you have to write them in C#. You can see a lot of my functions are written in C#, but we're releasing the functionality that allows you to author a function with Grasshopper. So when I click new function, new Grasshopper function, I can go find my definition, and I can drag and drop it in. It's going to go read the contents of that definition and figure out what the inputs are, what the outputs are, what the name is, what the description is, so that it can sort of put it into our library. And sometimes this takes a minute. And when it's done, we should see model output, whatever our inputs were, which were x, y, z, and curve. And we can hit publish function. Hypar is sort of like a cloud platform where people can share different sets of scripts or sort of model intelligence. So I can create a workflow that combines many scripts together. So I'm going to create a new blank workflow. I'm going to go look for psychedelic cuboid, and we'll insert it. And right away, we should see everything that I specified as an input, my x, y, and my z. And I should be able to like draw a curve, which is going to be my attractor. And hopefully this will work. This is like still really early beta technology, so there's a 50-50 chance that something will fail unexpectedly. But lo and behold, look at that. We've got now the logic of our Grasshopper script has been published to the web. I can change the dimensions of the box. I can edit the sort of raw geometry that I'm passing in. So it's not quite as flexible in human UI in terms of being able to like design a complex interface, but where it really shines is in the ability for you to publish this script in a way that other people can use it and connect it to the contents or the data coming from other scripts. So just to demonstrate, I can go grab another workflow here, let's say, where I'm going to draw an envelope. And I'm going to draw an envelope by site. Or actually, no, let's do an envelope by sketch. There it is. I'm going to drop it in. This function is written in C#, so this is not a Grasshopper function. This is going to allow me to generate some sort of parametric geometry. And Hypar functions are designed to just like seamlessly talk to each other. So if I want to drop a facade on this envelope, I can drop it in. And it's going to warn me that this function expects there to be some levels. So I'm going to add, and the function library will suggest for me that maybe I want some levels because this function needs them. So I'll drop those in. Maybe I'll change some of these parameters. I'm going to wind up with a little facade. And now what I can do is just plug one of the functions that I've written in Grasshopper directly into this workflow. So this is a way that I can take logic developed in Grasshopper and make it play with all of these other intelligent systems. So let's see. I think this is the one. Actually, I think I want, yeah, let's try it. I can't remember what this one does. I think this one, oh yeah, this one makes like funny little pillows, and then if I can make my spikes rainbow colored. But this is just written in Grasshopper. So this function is just a Grasshopper script that's being sort of integrated into this overall workflow, where you can, you know, just kind of have it talk to all of these other logical systems. So somebody should be able to, you know, build a logic of, you know, designing the massing, while somebody else builds a script for, you know, in C# for doing the structural design, and somebody else designs a Grasshopper script that does the facade modeling or whatever. And all of these things should be able to talk to each other fluidly. Let's see, what happened to my fins? I had like a cool, oh, shade? Yeah, maybe this one. I think this is the one. I'm gonna get rid of my, yeah. I think so. I'm going to get rid of my spikes. I think this definition, yeah, this definition uses the facade that's generated and then creates like a shading structure that protrudes over the facade modules. So Fernando wants to know if this is the place where you can sell a service. And the answer is absolutely yes, although not quite yet. So we are aiming to enable you to basically take your logic in whatever language or whatever form it might live, you know, if it's a Grasshopper script or whatever, and contribute it to the sort of global marketplace and then profit by it. So you should be able to, you know, make a little money every time someone uses your function. We are definitely moving towards that, although that's not currently available. Antoine wants to know if there are any limits to what Grasshopper components can be used in the definition. The answer is we just locked this down. So currently there's only a small handful of plugins that are supported. And spoiler alert, they're all like my plugins, plus Clipper, because Clipper's awesome. However, if you have like a really good use case, actually I suspect, no, Kangaroo may or may not work. Kangaroo is also a particularly difficult case because it works a little bit differently with the kind of like solution architecture of a normal Grasshopper script. It like might expire multiple times in order to like solve, which we don't support. The scripts that run on Hypar have to sort of run all the way through exactly once. Oh yeah, and this is iPad or mobile compatible, so you can actually like access this whole workflow on a phone or on an iPad or whatever. But yes, currently I think the plugins that are supported are Human, Tree Frog, MetaHopper, Wombat, Clipper, maybe one or two others. But if you have like a really serious need to use a plugin, like just let us know. We'll add it. It won't be a big deal. So anyway, that was a totally unplanned, I swear, little Hypar show and tell. We're obviously really excited about it. Yeah, telepathy is not currently supported, although on Hypar, but there's no reason why it shouldn't be. So that one we can add for sure. It does technically have some like magic, like solution logic in that it does like rewire itself and trigger a solution, but it really shouldn't be a problem for our purposes because it won't be rewiring itself on the fly. Antoine has a great question, which is about the limits on the size of a script. And that is a great question. Currently, there is sort of a hard limit on the Lambda functions that we can run. And so, yeah, if it takes more than, I don't know what our limit is because it's bracketed by a few other things. But I would say if it takes more than 30 seconds to execute, it probably won't work on Hypar currently. But again, if there's like a real serious use case where you want to be able to do that and your function is slow running, like talk to us. We'll figure out a way to support it if it does something really interesting. PH wants to know, does it provide the hint in regards to the type of geometry required? So say the script requires the input of a surface, but the base geometry is currently a polysurface. Will it work? So at least on Hypar, you specify the parts of the model that you intend to work on as dependencies. So there's a model dependency component here where I can say, I expect to get an envelope of data. And I expect to get floors, or I expect to get columns. And so you can set up your definition in a way that it expresses the things that it requires. Dan wants to know if we're running Rhino Common or if we're compiling from GH functions into Hypar functions. We are running Rhino Common. So this is basically built on, kind of Rhino compute tech, although we built a lot of scaffolding around it that makes it really easy to spin up and use. But yes, at the end of the day, there should be no functional difference between what happens in executing locally and what happens on our servers, and therefore everything that comes back should look the same. Now, the only real difference, and I glossed over this a little bit, is that the kinds of output you can produce need to be in Hypar's own geometry language, which we call elements. It's an open source library for representing BIM elements or geometry or whatever else. And so I just plugged in a mesh, which sort of auto converts to a Hypar mesh. But I can also construct an element and say, I want this to be a model curve. And this component will automatically basically instantiate the constructor of that thing. Or I want to create a panel or a column or whatever. And then it'll just reshape itself to provide any of the necessary inputs for that type so that you can be really directed about how you construct like BIM elements for Hypar's purposes. C# and Python components, I literally just blocked them like yesterday before it was permitted. We basically have to do this for security reasons. We don't really want anybody executing arbitrary code on our servers. However, if there is a good reason for this, we can find ways to put certain scripts or put certain definitions onto an allow list, in which case they would work fine. Luigi wanted to know about a genetic algorithm. So currently, Hypar doesn't by default build in a genetic algorithm. It does build in some sampling. So for instance, if I decide that I'm not sure what I want my envelope to be, but I don't know really what I want the building height to be 80, but I don't know what I want the setback interval or the depth or the tier or the foundation depth to be, I can tell it to sample these spaces and it will create many alternatives for me. And currently, we're not applying any sort of meta heuristic that would automatically calculate the best for us, although you can sort by any analytical results. So you can say find me the one that has, the lowest cost or, the highest volume or whatever data you're passing out. But we definitely have in the works the ability to do some kind of optimization routines. Damn, this is more popular than Human UI. I guess I joined the right company. Any plans to expose an API or invoke function workflows remotely? Yes, absolutely. We want to do this. Hypar really aspires to be a kind of toolkit for building applications around AEC. It becomes a common language to represent building elements. It becomes a way to describe the behavior of systems, but also just a toolkit that you can use to build your own custom applications. So we do not yet expose a public API. If there were a really, solid argument for us to do this, and in fact, we're already in conversation with a number of potential customers who are interested in API access, we can absolutely do this. I mean, we're using that API ourselves. We just haven't exposed it publicly. But if you wanted to make, a white label, AntoineDao.com app that uses Hypar as its geometric backend, we could absolutely use that. Oh man, there are so many good questions. I am struggling to keep up. Okay, Dan wants to know, are those element types specific to Hypar, or is it like classes and I can define my own element type? Which is my favorite question, because check this out. So you can define any element type you want. Elements is fundamentally extensible. So Elements is first of all open source. So you can go to hypar.io/elements on GitHub, and you can see the source of our own BIM library, our own elements library. But you don't even have to contribute back to this in order to define your own data types. So we support JSON schema for all element types. So even though these are owned by Hypar, they are not special. Any user could do this. You just define the type that you want to work with, like a level, define what its properties are in JSON schema. And I can go, so if I go look back here, I showed that when I did a construct element, it has all of these types. Now, if I want to create a level, you'll notice level is not one of these. I can just grab the URL to the JSON wherever I've hosted it, and I can use this Hypar setup component, and I can just pass it a reference to that schema, and it will download it on the fly, compile it, load it into the app domain, and then now I should be able to use construct element to create levels. So it's totally open and extensible. You can create your own custom types, and they're first-class types in the Hypar system. And I like Raphael's question. If you want it to do slanted walls, we'll make it do slanted walls. That's definitely worthwhile. And Raphael wants to know about the difference between elements and IFC. So this is a great question. Elements are built-in compatible with IFC. So anytime you build a Hypar workflow, you can go down to export and hit IFC, and you will get IFC that's compatible with any number of platforms. However, IFC is like a super rigorous and structured system. And we fundamentally wanted to make something that was more open and extensible. So I highly recommend reading the README on elements, because we basically articulated why we went to create our own system. We wanted something that was small and fast. We wanted something that could run in microservices on Linux for obvious reasons. We wanted something with great visual documentation. One of my favorite things about Elements is that if you go to Hypar and then you go down to the link about our free development tools, you'll get to our docs, and you can actually see, where is it? Hold on, I'm zoomed way in. If you click Elements here, you'll get to the Elements docs. Every Elements type, let's pick something fun, like a mesh. Oh no, does it not have one? Let's try a polyline. Let's try, oh, here we go. So our docs actually have built-in 3D documentation. So we wanted to build a library that would sort of self-document. So all we have to do is write a test in the library, and that will show up as 3D documentation for our our elements documentation. We did want to be able to serialize to formats like JSON, IFC, and GLTF. So you get a JSON model GLTF or IFC right out of the box just by using elements. We wanted something that would support like .NET. So Elements is .NET native, so it will work perfectly well in your Grasshopper scripts, in your Dynamo scripts, in your Revit plugins, like whatever. And the serialization, deserialization stuff is really beautiful. And that's a lot of what powers even the Hypar library. So, you know, if I wanted to say, take this model, for instance, I can just click JSON and I can download a representation of the entire model. And I can now, once it finishes exporting, I can import it into Hypar and just start working with it. So, we support .NET, but it's designed to be a super interoperable format in that we're just using JSON as kind of like the base representation. So it should be trivial to extend this to support, Python. And in fact, we've already done some prototyping on Python functions. So let me just like drop model.json from this zip file onto the desktop. Even this, I think, will probably be more streamlined in the future, but I'm going to grab that path. I'm going to paste it, and I'm going to use the dependencies component. So this is how you would specify like a dependency on something else, and we'll just say, I don't know, envelope or whatever. And now this is going to give me back all of the elements that live in that model. So I've got profiles, I've got materials, I've got floors, I've got things like that. And envelope is a really good example of one of these like custom types. So in fact, I need to go get the envelope schema. I'll go get a reference to it. I'll plug it in here. I'll do setup. And before, it wouldn't have been able to deserialize envelope, but now it can. And now I can even say, only give me the envelopes from this model, and I can use deconstruct element to get back out that envelope. So this is the envelope that was living in that model. So we have like, really easy I/O from the web interface to the kind of local interface. And just by having done this, I can now write a function that works on that envelope. I can deconstruct the brep. I could go, make a, I don't know, I can make a face center. I can put mesh spheres on it. Whatever I want to do. This is a function. Like, I just say model output. Here it is. Here's spheres, whatever. And we'll just say envelope spheres. Probably not a very useful function. And we'll just go back to Hypar, go home, create a new function, drop our envelope spheres on there. Man, this turned into more of a Hypar webinar than it did a Grasshopper webinar. Don't tell my bosses. We aren't even publicizing this yet. The other thing I'll say while we're waiting for this one to load is we would love to have the folks who are on this live stream, who are interested in this stuff, to come join us on the Hypar Discord, which is our kind of like community forum, chat platform. And this is the place where we're having conversations, where people are getting added to betas, stuff like that. So yes, actually, Andrew, would you mind putting the link to the Discord in there since I'm busy? Well, we'll see that. So let me see if I can add my spheres here, envelope spheres. So provided I haven't done anything totally illegal, this should now generate spheres on the basis of that envelope. So the vision is that, the logic can come from anywhere. It can be C#. It could be Python, it could be an Excel spreadsheet, it could be another Grasshopper script, and you should be able to just easily compose generative models that pair all of this logic together, that just bring things to talk to each other. I think one of the hardest things about doing genuine, detailed, professional work in Grasshopper is that, like, you run into this problem that the Grasshopper script got too complicated. It got too big, and only one person knows how to work with it. And our vision is that it should be much easier to decompose these systems into encapsulated logic where everybody's responsible for kind of like one system or one set of systems. And it should be really easy to get all of these systems to talk to each other, regardless of what language you're using, you know, what tools you're using, whatever. Like, it should be really easy also to get this stuff back into Revit or back into Rhino or whatever needs to happen. So that's, you know, that's my martini-fueled spiel. I'll probably do like a more serious and less inebriated version of this at some point, so stay tuned. Man, like I thought people wanted to talk about human UI. I guess Hypar is the new shit. I guess that's a good thing. So I do have to run here fairly soon. I will hang out for any last questions, either about Hypar or about human UI. And yeah, one more. Okay, I'll try and get. Let me see if I can get the Discord link real quick so that I can post it in the chat, because it really is. It's become kind of an amazing community. We, you know, Phil Bernstein has been hanging out talking about the future of the practice. We've got, you know, a lot of the you know, most amazing people in the industry working with us, both talking about the technology, but also just talking about, you know, kind of the consequences of automation for the future of this industry, which is, you know, one of those questions that I think we should all be concerned with. Finding the link. Okay, here it is. Okay. Dan wants to know, would you host the element types on Hypar servers versus using JSON files to define each time? So we've been talking a lot about this. That is like $1 million question. So right now, anyone can host their element schemas wherever they want, but we are definitely talking about having like a consolidated central library of kind of all of the public schemas that are available. There's a provision for maybe you have, you know, your firm's internal structural schemas or whatever, and you don't want to share them with the world. That's totally fine too. We support all kinds of like privacy controls and, you know, protecting the logic of your definitions and stuff like that. But we do think that in order to facilitate this kind of like communication between different kinds of systems, it will be important to have sort of a central representation of the classes, the types, the schemas, the contracts between functions. And yes, Hypar does use WebGL. When we break down Grasshopper to smaller sizes, how are you using a file control like Git? So we are not currently doing anything particularly special with version control or Git for Grasshopper. They're just kind of fundamentally incompatible, except, I mean, well, there was like a hackathon project I worked on once with Dan, actually, on doing version control with Grasshopper. But that's neither here nor there. I think, you know, one of the things that, you know, this allows, or at least will allow in the future, is the ability to, you know, have kind of like versions of your script. So like Hypar functions support like, you know, a kind of private version that maybe you can release to the public when you know, when you share it and things like that. And I think there are a lot more like controls we can enable, and we can maybe hold on to prior versions in case you ever need to revert stuff. But Grasshopper is just not in and of itself a really great collaborative environment, and it's not really easy to build or to kind of use in tandem with tools like source control. So I think there's probably a lot of work to be done there, but I think the first step really is in kind of distilling your massive, hairy definition down to a few kind of well-defined components, individual functions or logic that should sort of stand alone. And one of the things that I like about the Hypar plugin, this is by design, is that it sort of encourages you to set up your definitions that way in the first place. It encourages you to designate these are the inputs, these are the outputs, these are the requirements, this is what I expect to get, this is how it is intended to work. And that facilitates the kind of common exchange and plug and play nature that our system facilitates. So, in any case, I have to run. Thank you all for coming. I hope that those who showed up for Human UI were not disappointed by the extent of the other stuff, but this was fun for me. If you're interested in the Hypar stuff, please join us on the Discord. Feel free to reach out with questions or thoughts or ideas. If you have some amazing Grasshopper script that does some crazy stuff and you want to see it on Hypar, I want to talk to you. We will figure out how to make it happen. Yeah, that's it. Yeah, thank you all for coming. Enjoy your weekends.